Welcome. Today we'll learn how to draw the Lewis dot structure for potassium perchlorate, or KClO4. First, let's identify the number of valence electrons for each atom. Potassium, being in group 1, has 1 valence electron. Chlorine, in group 17, has 7 valence electrons. And each oxygen atom, from group 16, has 6 valence electrons. Let's calculate the total number of valence electrons. We have 1 potassium with 1 electron, 1 chlorine with 7 electrons, plus 7 4 oxygens with 6 electrons each, plus 24 for a total of 32 valence electrons. Now, let's start drawing the structure. First, we'll place chlorine as our central atom, since it's the least electronegative non-hydrogen/nonmetal. Then we'll connect the 4 oxygen atoms to chlorine with single bonds. Now, let's add the remaining valence electrons. We've used 8 electrons in our single bonds. That leaves 24 electrons to distribute. Each oxygen atom gets 3 lone pairs for a total of 24 electrons. Let's check the formal charges. For chlorine, 7 valence electrons, minus 4 bonding electrons, minus 0 non-bonding electrons, gives a formal charge of plus 3. For each oxygen, 6 valence electrons, minus 2 bonding electrons, minus 6 non-bonding electrons, gives a formal charge of minus 1. The potassium ion forms an ionic bond with the perchlorate ion. Potassium loses its 1 valence electron to become K+, while the perchlorate ion has an overall charge of minus 1. And that's our complete Lewis structure for potassium perchlorate. Notice how we've shown both the ionic bond between potassium and perchlorate and the covalent bonds within the perchlorate ion itself.